Okay, this video is to talk about the solutions to the angles and circles requiz. Okay, as background, you have 4 rules that you have to know. Each rule about finding the angle's measure and how it relates to the arc depends upon where the vertex of the angle is. In rule number 1, the vertex of the angle is at the center of the circle. In that case, the angle and the arc have the same measure. Rule number 2 deals with angles who have their vertex on the circle. If that results in being formed by 2 chords, we call it an inscribed angle. But in any event, when the vertex is on the circle, the angle is half of the arc it intercepts. Rule number 3 deals with arc angles whose vertex is inside the circle, not necessarily at the center. In that case, the angle cuts off an arc. Its vertical angle cuts off an arc. The angle is the average of the 2 arcs. You add the 2 arcs and divide by 2. And in the last case, the vertex is outside the circle. It's a very similar rule to the rule up above on the inside. Notice how the inside arcs chords sort of make a plus sign. That might remind you about the plus sign here. When the angle is on the outside, or the vertex on the outside, you subtract the 2 arcs and divide by 2. So there's your rule. Okay, so let's try to apply those rules on the quiz. Okay, on the first problem, I have an angle 1 that has its vertex inside the circle. So I'm going to use the rule that it intercepts an arc, which happens to be a 60. Its vertical intercepts an arc, which is a 50. Well, the rule says that that angle, the measure of angle 1, is equal to the arcs added and divided by 2. So that would be 60 plus 50 over 2. Well, 60 plus 50 over 2 is 55, and that's your answer for the measure of angle 1. The measure of angle 2, well, its vertex is on the circle. So it follows the rule that says the measure of the angle is half the arc it intercepts. Well, angle 2 comes out and intercepts, or cuts out of the circle, this 60-degree arc. Therefore, it is 60 divided by 2 for the measure of angle 2, and that's the 30 degrees you see as your answer there. The measure of angle 3 has nothing to do with circles directly. It has to do with the fact that angles 1 and 3 are a linear pair. And we've known since last fall that linear pairs are supplementary. In other words, their measures add to 180. So to find the measure of angle 3, I'll just take 180 and subtract away angle 1, which we figured out to be 55. And 180 minus 55 is the 125 you see here. Okay, over on our next diagram. Again, we have angles that have either their vertex at the center of the circle or somewhere inside, either that or on the circle. Okay, let's see what we know here. Well, we want the measure of arc AB. Arc AB is intercepted by this 20-degree central angle. Well, since it's a central angle, the arc will also be 20. Central angles and their arcs are the same. Because of that, notice that segment AC goes through P, and that's the center of the circle P. Therefore, arc ABC is a semicircle. Semicircles have measure 180. So if I take 180 minus 20, I'll get this 160 for the measure of arc BC. This angle ADC, it comes down here and hits one end of my diameter, goes over there and hits the other end. So this angle up here is half of my semicircle. Because its vertex is on the circle, it's half of 180. It's a 90-degree angle. And there's the measure of angle ADC there at 90. Okay, to get the measure of arc AD, well, notice that this 40-degree angle intercepts that arc. Well, remember, if the vertex is on the circle, the angle is half the arc. So if I put a variable there just for a second and call it y, then I would know that 40 is half of whatever y is. So if you just multiply by 2, you'd get 80 is that arc. And that's our answer for the measure of arc AD. It's 80. To find the value of x, well, let's notice that in this triangle DAC, we removed 90 degrees because that's a 90-degree angle. That means these two guys have to add up to the remaining 90 degrees. So over here I've got my solution. It says 2x plus 40 equals 90. Subtract 40, 2x is 50. Now divide by 2 and you'll get your answer. X is 25. On our next diagram, we have a 50-degree angle here. It intercepts an arc, which is x, is what we're trying to find. Its vertical intercepts an arc, which is 20. The rule says when the vertex is on the inside, the angle is the arcs added divided by 2. So if you look right here, I've got my equation. It says 50 equals 20 plus x over 2. If you multiply by 2, you'll have 100 is equal to 20 plus x. And now let's subtract the 20, and there's your answer. X equals 80. Okay, so now I've got this 80 over here I can fill in. Okay, angle 7. Angle 7 has its vertex on the circle, so it's half the arc it intercepts. It intercepts a 20. So angle 7 is 20 divided by 2. It's the 10 that we see right there. Angle 8 intercepts the 80-degree arc. Therefore, angle 8 is half of 80. It's the 40 you see there. Okay, on our next one, now we have a vertex that is outside the circle. It's way down here. The rule says that the angle for x is the arc subtracted over 2, but we don't originally know arc xy. Well, what we're going to do is use the fact that circles contain 360 degrees and all their arcs added up, and we know every arc of the circle except for this one up here. So if I add together 100 plus 40, that's 140, plus 80 is 220. That leaves us 140 degrees for the arc we didn't know. In fact, that's the answer. Measure of arc xy is 80. Now if I form the equation, and I'm going to write it again so it's a little more clear, write it right here. The equation would be that the angle for x is equal to the arcs subtracted over 2. That's 140 minus 40 over 2. If we multiply by 2, we'll get 8x equals, and then 140 minus 40 is 100. If we divide then by 8, we'll get our answer. X is 12.5. Okay, here's our next diagram. All right, what we have here is a situation where this angle whose vertex is on the outside is formed by a tangent line, PB, and a tangent line, PA. Tangents, remember, are lines that intersect the circle in exactly one point. We have a special rule for this situation. And in this particular case, the angle, x in this case, and the arc closest to it will always add up to 180. So what we have here is that 60 is what we need there to add to 120 to make it 180. There's your answer. To find the measure of arc ACB, just notice that ACB is the rest of the circle except for the 120. So if we just take 360 for the whole circle and subtract away 120, we have 240 degrees for the measure of arc ACB. Finally, the measure of angle ACB, that's this angle over here, notice that it intercepts a 120-degree arc. Well, its vertex is on the circle, so the rule is the angle is half the arc. Your answer is 60. 60 is half of 120. Okay, here's our last picture on the quiz. Okay, our given information here, let's see. I've written a couple things on here. It's hard to see what was given. Um, believe that it was angle 5 that we were trying to figure out, and we were given this 120-degree arc here. Now here's the key. This is circle R. That tells us R is the center, which makes TW a diameter. Therefore, arc TVW has 180 degrees in it because it's a semicircle. If I take 180 minus this 120, I'll have 60 degrees for arc VW. And now angle 5 is an angle on the outside of the circle. Its vertex is outside the circle. We'll find the measure of angle 5 by taking the 120 minus the 60 and dividing by 2. 120 minus 60 over 2 is 30. And those are all the solutions to the problems on the requiz.